So now that we have a basic understanding of what occurs in a redox reaction, we need to look at the procedures to balance redox reactions. So much like any other type of reaction, redox reactions require the conservation of mass. So basically, if I have 2 calcium ions on the reactant side, I need to have 2 on the product side. And so on. So that fact remains true for redox reactions. However, a conservation of the number of electrons that have been gained and lost also needs to be conserved. So there's a new nuance associated with balancing redox reactions. I also want to share a couple of new definitions. So previously we were able to identify the substance being oxidized and the substance being reduced. And some vocabulary that you must be familiar with are your oxidizing agents or your oxidant and your reducing agents or your reductant. So oxidizing agents, guys, that's the substance that causes another reactant to be oxidized. So basically, an oxidizing agent is a substance that accepts electrons and allows a different reactant to be oxidized. A reducing agent or reductant, it's a substance that causes other reactants to be reduced. So basically, a reducing agent gives its electrons up to a different reactant and is subsequently oxidized. So these can sometimes be confusing for people, but please make sure that you spend some time getting your understanding and thought process correct here. Now, being able to identify your oxidant and your reductant is what's going to allow you to write something called a half reaction. We're going to look at that next. So with a half reaction, basically what we do is we break up chemical reactions into their oxidation step and their reduction step, and we treat them as 2 separate pieces. So if we're given a reaction like this, what we would do is we would take or figure out which step or which ions or which substances are being oxidized and which ones are being reduced, and we would write them into 2 half reactions. So if we want to go ahead and do that really quickly. So what we probably want to look at really quickly is the oxidation numbers. That's going to help us figure out what's being oxidized and reduced. Okay, so 10 on this left-hand side, on the reactant side, is +2. It's +4 over here. So if we look at this, we're going from a +2 to a +4 oxidation state. So we've lost 2 electrons. Okay, so 10 in this case has been oxidized. Okay, and if we look at the transition from iron to iron +3 to iron +2, notice that we have gained 1 electron. Okay, and so this is going to be your reduction step. So when I go to write that half reaction setup, I'm going to write my oxidation step. So basically SN2+ is going to go to SN4+. Okay. And when we go ahead and we look at our reduction step, we're going from, let's see, Fe 3+. Okay, so we have our oxidation and our reduction step. If we look at this from the perspective of what's happening with our electrons, so in the oxidation step, this 10 2+ ion has lost 2 electrons, so it's going to be, or they are going to be a product on this side, on this right-hand side, which makes sense because if we look at our overall charges on the right-hand side, +4 + 2- will give us +2 on this side, which will equal the +2 on that side, so our charges are equal. If we go ahead and look at that same perspective for the iron, we're going to add 1 electron here because 1 electron has been picked up in the reduction process to give us our Fe2+. So these 2 are your half reactions and how you would write them. If people ask for just the half reactions alone and that's all that they want, I would take this step here in terms of adding the electrons to the appropriate side. However, when we're writing half reactions for our redox balancing for the overall reaction, I would suggest you hold off on the addition of the electrons.